Hello, trig class. I think it is working. So, what's happening? Let's do some math here. Today is the first day of trigonometry, and we are going to study something called radians. It's the first day of section 4.1. And a radian is just another way to measure an angle, rather than degrees. It's much in the same way we can measure distances in kilometers, and we can also measure distances in miles. There's different ways to measure, different units to measure angles, and one way is degrees, and one way is radians. Okay, and so we will learn about that today, and as you can maybe imagine, we'll go back and forth. We'll be able to convert radians to degrees and degrees to radians and that sort of thing. So the other thing that we should learn is that in trig class, we always measure angles from the positive x-axis. Okay, so we measure angles from the positive x-axis. See if that glare can get off your screen. And then we'll go counterclockwise. So let's talk about that. So, for example, if we stay in degrees because you're more used to that, this angle might be 45 degrees. Notice that we started on the positive x-axis. So this one might be 110 degrees. This one. Okay, so it's also true, and you might not be used to this, but sometimes we have more than 180. So this might be 90, 180, and then say 210 degrees maybe. Okay. The other thing that's true is we could go negative. And so maybe this is negative 40 degrees. Or negative 200. And you might be like, Mr. DeNeve, isn't negative 200 the same thing as, say, positive 180? And you would be right. So we say that those angles are what's called coterminal. We'll get into that more in the next lesson. It's also true we have negative angles. We have angles more than 180, but we can have angles more than 360. And so like this one is 450. So 360 plus 90. All right. And maybe this one is 720. It went around twice. And so if you've ever seen Mr. DeNeve in the gym jump up and spin twice and then dunk it, then that's a 720. If you've ever seen him spin just 1.5 times and dunk it over his head backwards, like that, then that's 540 degree dunk. Okay. Bet you didn't know you were getting a lesson and a show today, but you are. All right, so a radian is defined as in the following way. Pi radians is 180 degrees, okay? And the reason that is like the most common circle is the circle that is centered at the origin and has a radius of 1. Its circumference is 2 pi times r, so 2 times pi times 1, or 2 pi. And so the circumference of a circle whose radius is 1 is 2 pi, okay? And so if 360 degrees is is 2 pi radians, then if we just sort of reduce that, pi radians is 180 degrees. And so just to give you a couple of examples here, so this would be 90 degrees in degrees, but it's pi over 2 radians. All right, those are the same thing. And so maybe this is, 1/3 of the way. That's a 60-degree angle, but it's also then pi over 3 radians. And so as mentioned on this homework assignment, one thing that you're going to be doing is just changing degrees to radians and vice versa. And so let's just show you the homework assignment here. So on number 2, it says convert each degree measure into radians. And so that's -240. Now, if you really want to draw it, you could. And so like -240, you'd be like, okay, that's there. And then you could do some fraction work, right? You'd be like, all right, well, that's a whole pi, that's 180. And then another 60 is 1/3 of that, so that's -1 1/3 pi. And you might be like, whew, Mr. DeNeve, that seems like a lot of fraction work as we do it. And that's true. And so instead, just like we do in practical math or in chemistry class, we just set up a conversion sometimes. And so since 180 degrees and pi are the same thing, we can just multiply by pi over 180. And then we can do some reducing. And so since 60 goes into 180 3 times, and 60 goes into 240 4 times, then we say, oh, that's -4 pi over 3. Okay, so let's just do another one over here. This 170, all right, if we multiply that by pi over 180, that's 17 pi over 18 reduced. And so when we convert radians to degrees, we would do the exact opposite. So 5 pi over 4, we would multiply by 180 over pi. The pi's would cancel, and then we would have to do the math here. 5/4 times 180, however you want to go about that, but 4 goes into 180 45 times. And so this is 5 times 45, which is 225 degrees. And so number 9 here, 7 pi over 6, again, multiplied by 180 over pi. The pi's cancel. 6 goes into 80. 30 times 7 is 210. And so if you look at your assignment here, the first 20 of them are just like that. You're converting radians into degrees or vice versa. So we're going to either multiply by pi over 180 or 180 over pi, depending on which direction we're going. Okay, on the next part of the assignment, it talks about decimal degrees and degrees, minutes, seconds. And so let's go back to a blank piece of paper here. So there are 30 minutes. No, there's not, Darren. There are 60 minutes in 1 degree, and there are 60 seconds in 1 minute. And so this is just parts of a degree. And it's just kind of good math. Quite honestly, this is a bit outdated. They used to use this in navigation a lot, like with ships going a certain direction. They'd be, their bearing would be at 48 degrees and 22 minutes. And nowadays they just use decimals. It's easier on the computers. But the truth is that it's still good math, and so we do it. And so, for example, like 44 degrees, 30 minutes, that's how we would write that. That is 44.5 degrees. 30 minutes is half of 60. And so, how about like 41 degrees, 15 minutes, that would be 41.25. All right, because 15/60ths is a quarter. And so you might be able to think like that on some of the easier ones. But then, if you get to ones that maybe aren't as easy for you, 12 degrees, 48 minutes, you'd be like, okay, that's 12 plus 48/60ths. All right. And so this is one that you can probably do without a calculator. 48/60ths, 48 and 60 both go into, or both have a factor of 12. And so this is 4/5. And so 4/5 is 8/10. So that's 12.8 degrees. Now with your calculator, it's true. You can just, hit 12 plus 48/60ths. Boom, it's 12.8. And so if you got some that were a little more complicated, all right, so maybe 31 degrees, 12 minutes, 47 seconds. Notice the seconds have two little symbols on it. This is 31 plus 12/60ths plus 47 3600ths. Why is it 3600ths? Well, no one is here to answer that question. And so let me just tell you, it's, there are 60 seconds in a minute and 60 minutes in a degree, and 60 times 60 is 3600. And so since that's true, I'm waiting for it to come back into focus. Since that's true, that works. And so you're welcome probably on a problem like this. I shouldn't say probably. You're definitely welcome to use a calculator. So this is 31 plus 12/60ths plus 47 3600ths. And so we just write this decimal down. We're done 31.213 or so. So this is about 31.213. If you're so that's going from degrees, minutes, seconds to decimal degrees. If you're a little bit lazier than that, you'll notice on your calculator that you have a button right here. It's the second function of the apps key that's called angle. And so you could hit 31. You could hit that angle button and notice there's a degree symbol. You could hit 12, hit that angle button, and notice there's a minute symbol. And then you can hit 47, and depending on the age of your calculator, there may or may not be a seconds button. Mine does not have one. However, if I get out of there, if I go to the end and hit alpha plus sign, you'll notice that there's a second button. And then you just hit enter and it gives you that. And again, that's just a lot more boring than this, but I suppose it does save a little time. All right. Okay. And as you can imagine, the other thing that you'll have to do is go the other direction. So you might have to go from degrees that are in decimal form into degrees, minutes, seconds. So let's do a couple by hand. So suppose we had 45.8 degrees. We would have to say, oh, well, 0.8 is 8/10. So 8 out of 10 is what? I'll even put M for minutes out of 60. And you'll be able to calculate that M is 48. And so this is 45 degrees, 48 minutes. In a similar way, if you did, 37 degrees, 36 minutes, you would say, all right, well, I'm sorry, I'm going the other way. So if I did say, let's do a different one, 37.3 degrees, then I'd be like, oh, 3/10 is how many 60ths? All right, 3/10 is 21/60. And so the answer here is 37 degrees, 21 minutes. Now, it's true that on your homework, it'll be some problems that are a little bit more complicated. And so, like, for example, here on number 21, it says 95.6925 degrees. And so what we'll do is we can just type in 95.6925, and then there's a button when we hit second angle as we did before, and you can convert it to degrees, minutes, seconds, and it'll just do it for you. And that's just is about as boring as it gets. That's 95 degrees, 41 minutes, 33 seconds. And so you just got to do some button pushing there. Just for fun here, let's show you how you could have done that without the fancy button. So if you subtracted 35 because you knew it was going to be, not 9, I didn't mean to subtract 35. Sorry, you subtract 95 is what I meant to say. Because you knew it was going to be 95 degrees something. Then you say, okay, 0.6925, if you multiplied that by 60, that's 41.55 minutes. And so there's your 41 minutes that we got a second ago. See, 41 minutes. And then if you subtracted the 41 and then multiplied that by 60, there's your 33 seconds. And so that's much more interesting, more mathematical, I realize. Not as fast. And so if you find those buttons on your calculator, you're going to be in good shape on this particular assignment. Hope you enjoyed this lesson. We'll see you soon back here in room 261.